So I will be giving an overview of cloud and Azure, going over the services we're using to give the walkthrough to the example. And again, just for clarification, all the stuff that requires you to set something up or install something will be at the very end. So we're going to go over Azure first before we're going into our services, and then going into code, and then we'll have questions at the end. So what is Microsoft Azure at the start? Well, Azure is Microsoft's cloud ecosystem. It's a platform to provide functionality and hosting to any project. This includes something like website hosting or databases, or even things like artificial intelligence or mixed reality or augmented reality, and much, much more, from security to networking to pretty much anything that could keep a business, an entire business afloat, just built purely on Azure. But we're not businesses. Why would me as a student use the cloud? It's a great way to introduce functionality. I highly doubt a lot of us knows how to get a web server up and running from scratch. Highly doubt we know too much about machine learning outside of maybe tutorials, or maybe you're part of the AI club and just know a little bit more than the average person, but still not as much as working with maybe petabytes of data and training a model and getting that deployment environment up and running. A lot of real-world companies use the cloud nowadays, and because these big tech companies like Microsoft, Google, and Amazon really are all about it, they tend to like cloud technologies when they're screening resumes in case you're looking to get hired at one of these large tech companies. So some common Q&As that I see pop up every now and then is, what is the difference between Microsoft Azure, GCP, AWS, or anything else? Not really. There is not too much difference. It's mostly at the personal preferences. If you're using something like Heroku, which is another cloud platform that's pretty much only with hosting websites, like you won't get anything machine learning out of Heroku, but you would get it out of Microsoft Azure. Sometimes, yeah, features are included in one platform, not the other. But when it really comes down to it, outside of like the large three services, Azure, AWS, and GCP, it's more about the cost. I know that Google Cloud offers tons of free credits, and that's perfect for a hackathon. And so does Azure. I don't know about AWS and how many free credits they use, since I've never used it, but I'm sure they have something for students. And while there are free tiers, Azure is technically not free. You might still need to input payment information, even if you get free student credits. But we're trying to stick with free tiers where you'll never be charged, even if you do have to enter something in later. And lastly, why Python? Why can't we use, I don't know, C#? All of what you're going to see today is language agnostic. I'm not forcing you to use Python. It's just easier to read and follow in a workshop. So you can go ahead and like set everything up in JavaScript if you wanted to, or Java, or anything else. So how can we really use Azure for our hackathon project? Well, let's first go into what Azure can help us with in terms of the front end and the back end. The back end is code you can't really see. It handles a lot of data and logic and a lot of the under the hood stuff that people aren't really exposed to. And that's what we're going to be focused on today. But Azure, should you require it, can also give you a platform to deploy your website and get your website up and running for everyone to see, and not just you on localhost. So I talked a lot about file storage and databases earlier, and now we're actually going to go into what Azure offers you in terms of that. Databases and file storage are probably one of the most common services hackers tend to use in hackathons. In terms of databases, we have Azure CosmosDB. It's a NoSQL database that comes in a few different types. That's not exactly too important because we're going to be sticking to core, but for trivia, Azure CosmosDB comes in like a graph database type, or like a SQL database type, or a column store database type. All of that, not really too important for a hackathon, but it's good to know if you ever have to use this for like a senior capstone project where you do have to do a lot of research into the type of database you're using. Why would I need a database at all, though? When it comes to like making a website, demoing it during a hackathon, normally people try to go with like setting up a user account, or trying to pitch an idea that this data is personalized to you, and like this application you register using like your Gmail account, and you have all this like personal information that's like shared with the application. You can't do that without a database, at least without hard coding all the information itself and probably upsetting a judge who has to dig through your code and seeing, hey, there's actually no functionality, you just hard-coded everything. That's not good, but a database can help you with that. When it comes to file storage, I say the word file. It's not actually a database. When you store information in a database, you think about like, strings or maybe an array or an object. But a file storage helps you with things like, JPEGs or, MP4s, MP3s, literal files that you can open on like a Windows computer. That can't be stored on a database. You have to use file storage for that, but they're really closely interlinked. And when you talk about one, you typically imply a storage account if you mention anything with files, even though there are technically two different storages or two different services. All of the connections to these services are done through APIs, and we'll get into that a little bit later. So when we think about CosmosDB, it's a database, right? Data is organized in a database. You usually have one of them. Data inside of a database is separated by containers. You could have multiple of containers. But within a single container, you have these things called partition keys. And that's how data is sorted. Inside a container that relates to food, for example, this container only contains food. A partition key might be the type of food. Think about how you would sort food. If you had a menu at a restaurant, you sort the category of food by its type, like entrees or meats or seafood. That's an example, right? That's a partition key. It's not too important in understanding CosmosDB to understand all these different terms, but it would really help to get off on the right foot when we look at the code, because the code actually deals with these terms. And I'd rather we all start off knowing what these are before we actually look at the code. And by the way, if there's any questions, go ahead and drop it in the chat. I have that open, so don't worry. And in terms of file storage, data inside of Azure Storage is separate by containers, just like in the database. And partition keys don't exist, but instead your files are separated by the file type. So images or text files will be called quote unquote blobs. And you'll see that term later on as well. And things like a CSV, like a spreadsheet, you can store it as like a table. You can technically upload a whole CSV as a file, but there's a dedicated file type called a table that Azure tends to use when it comes to like CSVs that are, 50 gigabytes large that you can't really store as a file. When it comes to cloud functions, this is our last type of service that we'll be using today. Functions really refer to a snippet of code. So if you imagine a function that handles adding two numbers together, you have a function, header, add two numbers with two inputs, A and B. You return A and B. That would be a function. If you're familiar with programming, that would be, as complicated as it would be. Cloud functions refer to functions that exist on cloud servers. So you take this function, add two numbers, and you shove it on a server. You're able to communicate to that server through web requests, but it's still just the function itself, not a whole application, just the function by itself. The serverless part comes into play when we think about who's managing the server. The company's doing all the work for you. So in this case, Microsoft is doing all the work for you. All you have to do is write code, click deploy, and don't worry about it. All of that configuration, all of that deployment, the web request, everything regarding that is handled and is taken off your hands, and you're only able to focus on the code, which is perfect in a time crunch like a hackathon. So yeah, to reiterate, it's extremely lightweight and quick to code. It really speeds up your deployment process. And when it comes to getting a judge on your side, they like to hear things like, oh, I deployed on Azure, or I use some kind of technology that keeps code and services off my machine and on someone else's machine. It's more impressive to use cloud functions and anything cloud related, even though you could technically do it on your own computer. Knowing these tools would not only benefit you in the future, but would help you win projects a lot easier when it comes to pitching and showing off exactly what you did. When it comes to cloud function communication, yeah, we communicate over the internet. We can have it trigger with an automated timer, or even have the code listen to things in a database and automatically execute if it notices any changes. For example, if we have a user database that has like a bunch of users and we want some code to like send them an email when they sign up for a service, a Cloud Function can do that really easily. But a normal database or a normal code base probably can't. So how would we really use these services? Imagine we had a project that we want to pitch. We want to make a hurricane assistant website and mobile app where users who have their homes damaged in a hurricane can make an account, post images of their homes, and ask other users in the platform to help them with repairs. Well, use a database to store these information, of course, storage to handle image uploads, and Cloud Functions, where you can write code once and reuse the code for your website and mobile app without copy and pasting the code you've written in 2 different locations. All you have to do is make your website and mobile app talk to the Cloud Function over the internet, and that's it. You have a single piece of code that handles 2 separate applications, and that would be impossible if you had to write code twice because it's bundled together with like your mobile app, or it's bundled together with your website and it exists as part of your website instead of as a Cloud Function. If we wanted to make some kind of IoT project, for example, that keeps track of air quality to help people promote health and air quality health, while our database could keep track of the status of each sensor, our storage can keep spreadsheets of air quality data. And Cloud Functions is a lot more important here for this project because IoT devices, they don't have a lot of memory and they probably can't run an entire server like your laptop can. But what they do have is internet connection, at least most of the time. You can use Cloud Functions so that your Wi-Fi enabled IoT device can just communicate and send information to a Cloud Function on a server somewhere else and not have your little Raspberry Pi run a whole server locally. And finally, this is a project that I did that won Shell Hacks 2020 earlier. If you want to make a machine learning accelerated online learning platform that transcribes YouTube videos and converts into text, or even calculates how engaged you are based on facial recognition, your database would be used to manage user accounts just like before. Your storage account would handle MP4s, MP3s, and even audio files. And Cloud Functions really helped 3 separate people work together and build a whole project without pretty much ever cross-communicating. Our backend was written in 3 different languages, C#, Python, and Rust, and they all worked thanks to Cloud Functions. If we had a regular database, regular server, like a regular anything, we'd all have to stick to the same language. We have like merge conflicts left and right, and a lot of our time would be spent on like managing the code and not really writing it. And the final thing about Azure, it's a lot of information I know, but we'll get into the code in just a moment, is some terminology. This will come in handy when you're looking at the setup guide at the very end of the workshop. When it comes to Azure, because there's so many things that Azure has, Azure needs a way to organize all of that for you. So when you make an account, you have this thing called a directory. Your directory is tied to your account, essentially. Think of it as like a user account. Your user account is a directory. Inside of a directory, you might have a couple resource groups. As the name implies, a resource group in Azure is a collection of different services. A service might be a database, it might be a website, or it might be some AR or machine learning models. You can group these services up together by their purpose. Yes, you can hypothetically use one giant resource group for everything you can ever want, but in terms of organization, Azure does let you break it down so that similar services end up in the same resource group, so that it's easier to kind of manage when you have maybe 20 projects going along. So to recap, a directory contains resource groups. A resource group contains services. And a service is just a product you're using, whether it's a website, a database, some ML models, or anything like that. When you set up your Azure account later, Azure accounts come with one directory by default. And in hackathons, it's normal to use just your regular default directory and make a giant single resource group that holds all your stuff. And that's totally fine. It's not good practice for when you start working full time. But in terms of hackathon, when you have 36 or even 24 hours to code, that's perfectly okay. So pause here for a second. We're going to talk about the code. The code, again, is in Python. And I'm going to be expecting you to have maybe some basic Python knowledge, nothing too advanced. There's no like weird abstract libraries I'm using. I'm not making maybe APIs or anything like that outside of maybe the Azure functions that Microsoft handles for you anyways. So we're not doing too many things from scratch. So if you get lost halfway, don't worry, I'll try to get you caught up. So we'll start with Azure Cosmos DB and Azure Storage, since they're just so similar. Well, the basics are just regular Python code that runs your computer. Literally connecting to a database is 10 lines of code. You don't need to manage anything. You just access an API, import the right packages, and that's it. There's no server management needed, no special tools you have to install. It's as simple as getting a text editor, downloading Python, and just writing some code right away. When it comes to connecting to Cosmos DB, we'll start with that. As you can see here at the very top, we're loading up our correct packages. So in this case, it's azure.cosmos. Self-explanatory, right? For parts two, we have two variables I'm declaring here, our endpoint and the key. Since our cloud database is hosted on the internet, everything on the internet has some kind of URL related to it. For example, the endpoint for Google would be www.google.com. That would be an example of an endpoint. For your Cosmos database, it's going to be called something else, maybe like, I don't know, www.mydatabase@microsoftazure.com, something like that. You get the point, right? For key, that's like your password. If all we had to do to get access to a database was type in the right URL, then any hacker could break in and steal all your data. There wouldn't be any security. Your private key helps with that. Nobody's able to access your database without a private key. And that's something you want to keep close to your heart and don't post anywhere online. Afterwards, we initialize a Cosmos client that's just kind of predefined, like Microsoft wants you to initialize a certain way. This is not like a Python specific thing, it's a Microsoft specific thing. We do Cosmos client equals new Cosmos client with our two inputs, endpoint and the key. If you're familiar with object-oriented programming, that's really all there is. You're making a new client object that you can then work with. In part 4, we're making a new database. If you remember earlier, Cosmos DB has a database that has containers inside, and data belongs in the container. So part 4 and part 5 deals with first making the database. In this case, it's called demo database. Doesn't have to be a unique or even clever name. And then inside of that database, as you can see, we're making a new container inside the database. Notice this, Cosmos database equals Cosmos client.create database. And then Cosmos container equals Cosmos database.create container. Now, the reason why I wanted to go through the terminology at the start was because this is an example of where things would come up. We're seeing databases and containers and even partition keys. To recap, a partition key would be how you're going to sort your data. The examples I'll be going through later is working with food. So I'm going to be sorting my food data by the type of food. The last item there, offer throughput, you can pretty much ignore. It's not too important, but it basically just manages how many reads and writes your database can work with. If you use a higher number, that database is much more, you can say, I don't know, I would say the word like fast, but it's not really accurate. It's more like if you have 1 billion users all at once, your database needs to be faster than if you had 2 users that both, like, I don't know, live in the same house. So when it comes to creating an object in the database, as I mentioned earlier, all we have to do is call an API, right? So we got the Cosmos container object we made in the prior slide. Right here at the very end on step 5, Cosmos container equals Cosmos database.create container. We're using that object, and we're calling create item. And we're passing in this object right here. In Python, this is a dictionary. It has key value pairs. In JavaScript, this might be like, like an object. And over web request, this would be formatted as if it was like a JSON object, if you're familiar with that already. So all data in CosmosDB requires an ID. As we can see here, our type, our partition key, is a smoothie. This is a smoothie. Our data type can range from like a simple string to an array, or even like a whole nested object. There's no limitations to the format of the object you're putting in, as long as it's consisting of primitive data types like characters, integers, or strings, even though it's technically not a primitive data type. You can't put files in a database, if you remember. Files belong in file storage. This is with regular data. Now, when we call this, when we execute this line of code, we print out successfully created the object. It's as if it was normal programming. It's as simple as like ArrayList.add or like some kind of like inbuilt data structure, as if you were programming for like a homework assignment. There's nothing different from that. The result of that, as you can see, is in our Azure database. And again, if this page does not look familiar, we're inside of our Azure account right now. So this is on the website. Like I typed in azure.com and looked in my database. More on that at the very end. But as you can see, we have an item right here with ID 123, as we defined earlier. The type is smoothie, the name is fruit smoothie, and we have our items right here. As you can see, ingredients is still an array, and our properties is another nested object. That's pretty cool. When it comes to file storage, we don't actually use a key or an endpoint. We just have this thing called a connection string. If you're wondering why it's inconsistent, it's because different developers work on these products, and sometimes they just don't communicate with each other, and what one team does, another team might do differently. So like you just kind of have to get used to this from like large cloud companies when it comes to inconsistency. But you grab this connection string on step 2. Just like before, you initialize a new client. This time it's called blob service client. Blob stands for like image files, text files, or anything like that. And we make a new container, just like before for our database. And if you can probably catch the pattern, we use this container we make at step 4, and we just call container get this client and upload the data. In this example, I'm trying to upload this image called puppy. Puppy is located where my Python script is, as you can see in the bottom right-hand side. Puppy is local to my computer, but I want it to be on the cloud. So what I do is I get the file path, the file name, and get a reference to the object in the database, or the file store to be more precise. And all you do is call upload. And that's it. At the very end, you can see that the file ends up being on Azure. So the great thing about all of this is there's barely any code involved. As you can see, it was in total for both, like all 4 slides was, I don't know, like 20, 25 lines of code. It's not too complicated. But it's a really powerful tool to bring functionality into your project that you normally otherwise could not. In Azure, connecting to a database or storage account requires a container. These containers can be called and initialized by making some kind of API call based on a package that you import, as well as inputting some configuration keys that personalize it to your account. After you have a container object, you use APIs built into the container to do all the heavy lifting for you. Again, as I mentioned earlier, it's as simple as doing ArrayList.add or map.get. It's really that straightforward. So changing it up a little bit, we're going to get into Azure Functions in a minute. So Azure Functions is sort of its own API platform. Think of it like that. Unlike your CosmosDB or Azure Storage connection, this time you do need to go through some steps to make your own API. And that would involve deploying this service from code on your computer to the cloud before you're even able to test it. If you want to test it locally, you do have to install additional tools, but I won't be covering that today. And to reiterate, it means that you can't just run the Python code locally. You have to type out the Python code, deploy it, and then test it over the internet. You're not really running your own script. you're having the cloud run the script for you. So you communicate over the internet, and that's how you're really making your own API. So when I say API and web requests and all of that, I'm really referring to HTTP requests like GET or POST. These are communication protocols related to communicating with computers over the internet. The way we do that is through this thing called JSON. If you attended the Python workshop that happened right before mine, you might have heard this already. JSON stands for JavaScript Object Notation, and it's like a universal standard of information transfer. Meaning if you had a string that represented a JSON object, if you were to like literally go into Microsoft Word or like Notepad and type this out and get that into like a string, then a lot of other languages, or I'm pretty sure most, if not all languages nowadays, would understand what this information is trying to represent. For example, that string right there to the left-hand side where I'm talking about my name, it's Justin, my school is UCF, I can send this string from like a JavaScript website into a backend that's coded in Rust or Python. And these two services would automatically know that my name is Justin and I go to UCF. When it comes to really thinking about how this all pieces together, well, since we're talking over the web and this is like an API we're making, we have a web listener. So this would be like responding to a web request, for example. Our logic is just like regular code, like updating item in the database or like doing some calculations or something you might use for school. In our response, instead of returning like an integer value, we respond with some back and forth web communication. So you'd send a status code of 200 to represent everything's good, and maybe some JSON in response to signal that whatever operation you were trying to do has completed successfully. So what does this look like? Here we have an Azure function, and most of this is pre-generated by Microsoft. I don't know why they do things a certain way, but what this is kind of going on with, like it's expecting a web request. So like our main function, the input of that is an HTTP request. And you can get that HTTP request JSON body with just rec.json or get.json, for example. In order to access these fields, you can just, pretend like it's a Python dictionary because it converts it to a Python dictionary for you. And at the end, we can see that we have a successful response, and we can just print out the input back to us with a status code 200, as I mentioned before. It's a lot to kind of cover, but in the next slide, as you can see, we can just communicate with our function right here in the URL with a really simple hello world JSON body, and we get a response with a status code 200, took 120 milliseconds, and we can see that the input was a JSON string hello world, exactly like what we passed in earlier. You can also update a database through a Cloud Function. Since Cloud Function just runs, Python code, there's nothing stopping you from just copy and pasting the database code I showed you earlier into your Cloud Function. And instead of hard coding a data object to upload, you just get the object from the JSON body, post it into your endpoint, and you can see that the object is made, just like how we ran it locally without the Cloud Function. So that was a lot of code, but I have 2 links here. These links should help you get started on creating, updating, reading, deleting from the database. I know I only covered data upload in this workshop, as well as some basic Cloud Functions, but all of the functionality that I displayed here in this workshop today and more can be found on these 2 links. The first link deals with running local Python code. It's not a Cloud Function. You can just download Python, run the script locally on your computer, and see how it all works. The second one does require you have a Cloud Function sort of app deployed on Azure. So that one does require extra steps, and that's why I separated those two repositories in case you wanted one but not the other. So a little bit more about Azure services. I would like to give a shout out to Azure Cognitive Services. This really gave me a lot of Hackathon gold points essentially in the past, where we have a bunch of machine learning models that you can use without needing to know anything about machine learning. For example, you can do like web search stuff where you can like search based on images, like Google image search, for example. All of that through like an API they can write in Python. You can do facial recognition or like speech translation or like text to speech, speech to text, and even like a Q&A generator. Yeah, you can pass that Q&A generator a book, and that would scan through every single sentence in the book and generate questions and answers as if you're making flashcards. It's pretty amazing. And after this, if you're still not sure where to begin, yeah, start by looking through my code and running the Python scripts locally. And if this is the first time you're working with the cloud, try just messing around with the database and file storage system, like pass in different objects, see how it works, and like see what happens if you try to add 2 items to the same key. Like hint, you get an error. Like for example, like knowing these things and like just experimenting your own really does add up into a lot of knowledge, because then you can just innately know like, oh, I tried this before, it shouldn't work, instead of being stuck on more of the basic details. I do have time for questions in case anyone has any, but for reference, this is where the installation tutorial sort of begins. If you do have any questions after this workshop, please message me on Discord. But I can just like flip through all of these slides to show you what to expect. There's lots and lots of images on exactly what to expect every step of the way. So I hope that this all helps you when it comes to setting up Azure and getting this up and running on your local computer. Oh, I passed it. I was trying to show you something. Yeah, right here. We can make our own functions app and deploy it. And you can see exactly what I'm talking about when it comes to like this URL. The URL I saw earlier, this is how I got it. So like it's really like right in front of your face. And you can even see the code that you deployed in case you ever wonder what you wrote maybe 2 years ago and you don't remember. But yeah, that is all for my workshop today. If there are any questions, I'll stick around for another minute or two. But if not, thank you for attending. And I hope that through the slides, through the code, I really helped you get started with Microsoft Azure and give you the tools to essentially take all the hard work in getting this set up off your hands and have you focus on more of the ideas and project pitches, and not with figuring out how to set up a database, which, I don't know, might take 2 hours otherwise. So good luck in hacking, and thank you for attending.